Question 7 is a reasonably complicated analysis question. Let's have a look at what it says. It says B and C are ionic compounds of two different group 1 elements. The molar masses of B and C are both approximately, that's important, 140 grams per mole, so that's the MR of B and C. A student dissolves B and C in water in separate test tubes and analyses the solutions, and it gives us the observations when we've added nitric acid. One of them, B, has given us bubbles and C has given us nothing, and then separately if we then add barium chloride, then B has given us no change and C has given us a white precipitate. And then it says use this information and the observations to identify the formulae of B and C and explain your reasoning. Okay, so the command words are identify the formula, that's the key of what we're trying to do, and then explain why we've come up with that formula, so make sure we explain what it is that we're doing. Lots of information here that we are going to use. First of all, they are group 1 elements, that's going to be important. So we are talking about compounds of sodium, lithium, potassium, or one of the more exotic group 1 elements. Tells us what the molar mass is, so no doubt that will be important to us at some point. And then obviously what's key is the data in the table in terms of what happens when we do those two tests. So linking this back to our learning, what are those two tests? Well, adding nitric acid is the test for carbonate. CO3 2- is the carbonate ion, and if we get bubbles, that is the positive result, so that we know that B is a carbonate. C is not a carbonate because we don't get any change when we add nitric acid. We then add the BaCl2. The key thing we are adding there is the barium ions, that is the test for sulfate. Test for sulfate, SO4 2-, no change with B, but C gives us the white precipitate of barium sulfate, so that we know C is a sulfate. So given that these are both group 1 elements, then we know that B is X2CO3. Don't know what X is, it's one of the group 1 elements. It must be X2 because carbonate ions are 2- and the group 1 ions are all 1+, only two of them. And C is going to be X2SO4 for the same reason. So we need to work out what X is, and that's where we'll use the molar mass of 140 to help us with that. So let's get something written down. So we're going to say B bubbles with nitric acid, HNO3, showing it contains carbonate ions, CO3 2- ions. C forms a white precipitate with BaCl2 aqueous, showing it contains sulfate, SO4 2- ions. Really important there to show the link between the observation and your conclusion. So making sure you can't just say that B contains carbonate ions, you have to explain that the reason why it contains carbonate ions is because it bubbled with the nitric acid, and the same for the link between the white precipitate in C and the sulfate ions. Okay, so both of these, both contain group 1 metals which form 1+ ions. So B equals X2CO3 and C equals X2SO4. So we're on our way. 5 marks for this question, but we've still got a little way to go because we need to decide what X is in each case. So let's have a look at B. So the MR of CO3 2-, the carbonate ion, is 12 for the carbon plus 3 times 16 for the oxygen, which is 12 plus 48 equals 60. So if the total is approximately 140, then in this case X2 equals approximately 80, so X equals 40. And if we look at our group 1 metals, then the group 1 metal with an atomic mass of 40 is potassium. Okay, let's just say B equals K2CO3 brackets AR of K equals 39. So that explains that. Now if we look at C, then do it the same way. The molecular mass of the sulfate, SO42 minus, equals 32 plus the sulfur plus 4 times 16 for the 4 oxygens. That equals 96. Take that away from the 140, so x2 equals 44, so x equals, I should say, approximately 22. Therefore C equals sodium sulfate, because sodium equals 23. It did say approximately. Okay, so not too difficult, but really important that you write down your thinking and explain your logic really clearly and carefully, which is why it's worth spending a bit of time up front just doing this sort of stuff here, getting your head around what those tests mean, what the formulas might be, before you launch into your explanation. If you launch into your writing your explanation too soon, you might end up with something that's a little bit confused, a little bit unstructured.